Hello guys, good day and welcome. My name is Brent Paul Macasilhig and I'm your video host for today. So now let's move on. So the first is Module 3 Assessment 2. So the problem is photoresistor. A photoresistor changes the resistance of a circuit based on the amount of light that hits the sensor. In this project, the brightness of a LED will increase and decrease based on the amount of light present. So the parts needed are the following: one Arduino Uno, one USB A to B cable, one breadboard, one LED 5mm, one 330 ohms resistor, one 10,000 ohms resistor, one photoresistor, and jumper wires. So now I think we've understand that the parts. So now let's move on. So this is the plotted for my assessment in module 3 assessment 2. So as you can see, let's first check the parts. So this one is the Arduino Uno. This one is the LED. So we can change any color of that if we want. This is the photoresistor. Okay. This is the breadboard. All of these are the jumper wires. The resistor that has 330 ohms. And here, terminal 2 is above, terminal 1 is below. Then, here is the 10,000 ohms resistor. Remember that in the photoresistor, terminal 1 is on the left and terminal 2 is on the right. So, if the 2 is on the right, so the 10,000 ohms resistor, the terminal 1 should be on the parallel of the terminal 2, while the terminal 2 of the 10,000 ohms is on the other side. So now let's start. I will explain this because I've already plotted the parts. So this wiring, so the anode part of the LED is connected to the sensor pins, okay? So for the sensor pin that we use here is 2. And then here, for the cathode part, we've connected it to the negative terminal. So always remember, negative terminal is for the ground or the negative charge. And then for the positive terminal, it is for the power. So it has 5 volts. Okay. So as you can see, the resistor is connected to the negative terminal. Any of these connected will automatically charge the cathode. Then here, the positive terminal is connected to the terminal 1 of the photoresistor. And then the terminal 2 and the terminal 1 of both the photoresistor and the resistor is connected to an analog, which I've plotted here A4. And after that, this one, the terminal 2 for the 10,000 ohms resistor is connected to the negative negative charge or negative terminal. So now let's put this into code. So this is the code for the assessment. So constant integer sensor pin equals A4. Sensor pin here, because this is the one that will sense the what you call this, like earlier, the amount of light present, like the photoresistor. So it needs the sensor pins. So sensor pin is on the photoresistor connected to the analog 4. Next is constant integer LED pin equals to 2 because we've plotted in any of this. After that, this one is constant here. The INT light level, you can copy this one. This one is depending on where you plot the jumper wires. So INT light level, low equals 0, high equals 1023. So for the void setup, we have pin mode, open parenthesis, LED pin, and then output. For the void loop, we have the analog read for the sensor pin and manual tune analog write for the LED pin and LED level. So for the void manual tune, we've plotted here. Light level equals map. Light level 0, 1023, 0, 255. And then light level equals constraint, open parenthesis, light level 0, 225, 255. Always remember, always don't forget the semicolon after each function. So for each setup, you also need to not forget the brace. So we have here the auto tune na. So if the low is less than the light level, so low is equals to light level. So it will light even though there is low. Then if high is greater than light level, then high is equals to light level. So for the light level equals map, light level, low plus 30, high minus 30, 0, 255, and light level equals constraint. Light level 0, 255. So I think we don't have problems with the coding anymore. So you can automatically copy all this if you want to answer this module 3 assessment 2. You can copy the code. So let's start. There we go. Okay, so let's close the code first. Let's zoom. Okay. So we expect this one to light. So it is still dark. So once we move this one, oh, there we go. It automatically lights the LED. It will still be the same for the others. Okay? So I guess that's all for this video. Thank you for watching and I hope I see you next time. Peace out.